So in this video, we're going to talk about glycogen synthesis, right? So we're going to talk about glycogen synthesis and the process of glycogen synthesis. So essentially, we take glucose, glycogen synthesis, we take glucose and we take glucose and we convert it. So we convert glucose to glucose 6-phosphate, right? We take glucose, converts it to glucose 6-phosphate, right? This enzyme in uh, the hepatic cells and beta cells of the pancreas is via glucokinase. Right? Now what happens is that we have to form glucose 1-phosphate, and we do that through a reversible reaction, and we form glucose 1-phosphate, right? So this is important. Now the enzyme that does this reaction is phosphoglucomutase. Right. So this is a mutase reaction. The only thing we're doing is changing the phosphate from one position to the other. Now, the reason why we create glucose 1-phosphate is because we have to create a high energy glucose molecule. And this is where we come in the form of using UTP. Right. So I'm sorry, this is terrible. Let me write this better. So we use UTP in this step. So we use UTP along with glucose 1-phosphate, and the enzyme that we use in this reaction is UDP glucose pyrophosphorylase. Right? We form a double inorganic phosphate as a byproduct, and we create UDP glucose. I could also write it as UDP, and I'm going to use a dot as glucose. So we need glucose in this form because this is the form that glycogen synthase, which is the enzyme that does glycogen synthesis, recognize. However, we actually have a problem. Glycogen synthase cannot just use UDP glucose to attach glycogen synthase just cannot use UDP glucose for glycogen synthesis. It actually needs a primer, and this primer comes in the form of actually what we call glycogenin, right? So in your biochemistry courses, you will see glycogenin, and glycogenin is essentially a protein that has tyrosine residues, right? So glycogenin is a protein that has tyrosine residues. It's actually found inside of glycogen granules. So this is glycogenin, right? So this will be glycogenin. So what essentially happens is that glycogenin takes UDP glucose and starts forming these glucose molecules on the tyrosine residues, right? So essentially what we have is glycogenin with the oxygen, and it's forming these glucose residues on its tyrosine on the tyrosine chains, right? So it's using UDP glucose, taking the glucose off to attach to the tyrosine residues, and it's releasing UDP as a byproduct, right? So it's releasing UDP as a byproduct. Now these, right? So it's using UDP as a byproduct. So glycogen synthase now can now act because this serves as the primer, right? Because remember, glycogen we said serves as a primer, right? glycogen synthase needed a primer. So glycogenin serves as a primer, and so glycogen synthase now can act by using UDP glucose So glycogen synthase can now act, because of the result of the primer, to use UDP glucose to continue synthesizing the alpha 1,4 bonds. So this would be, again, my glycogenin. There's the oxygen, and these are glycogen synthase adding my glucose residues, right? So again, these are in the form, all these bonds, right? And it's just going on and on and on, right? These are alpha 1,4 bonds, right? So these glucose that are getting synthesized, they're in the form of the alpha 1,4 bonds. Now, interestingly, at the end of these molecules, we have what we call non-reducing ends. Now, this is important because remember, glycogen is a branch structure. It's not only just a linear structure. So we talk about glycogen synthase adding glucose in the 1,4 direction, right? 1,4 linkages, but it is a branch chain. It is a branch structure. And so glycogen synthase also has what we call a branching enzyme, right? So the branching enzyme, which is also called branching enzyme is also called 4,6 transferase. So this is the branching enzyme. I'm going to put BE for the branching enzyme. So what the branching enzyme does is that it goes to the non-reducing ends and takes about 6 to 8, right? So it takes about 6 to 8 of these glucose residues, cleaves at the 1,4,6 position, cleaves at the 1,4 position, and then add branch chains to the 1,6 position. So in other words, I still have my glycogen in here. Here's my oxygen. Here's my glucose residues in a 1 connected by 1,4 bonds, and it's going on and on. But again, remember I said these are reducing ends, and 4,6 transferase, or the branching enzyme, takes about 6 to 8 residues off the non-reducing ends, and then start adding 1,6 linkages. Right, and I don't have any space, but you get the idea. 1,6 linkages. And then glycogen synthase still continues, and the cycle continues. So glycogen synthase come again, synthesize, and then 4,6 transferase comes, takes a couple portions off, and then add another piece. And ladies and gentlemen, this is how glycogen is synthesized.